All right, so this is baby real analysis problems that I'll be doing that go along with if you're following the lecture series on YouTube. And this is problem number 3, and it's taken out of Bartle's Intro to Real Analysis 4th edition textbook, and it's in section 2.2, exercise number 2. So the problem is that a and b are real numbers, show that the absolute value of a plus b is equal to the absolute value of a plus the absolute value of b if and only if the product a times b is greater than or equal to 0. So that is what we're going to show. And I am going to first, so proof, I'll do this direction first. So I'm going to do the case in which assume that the a times b is greater than or equal to 0 for wish to show. So WTS for wish to show that the absolute value of a plus b is equal to the absolute value of a plus absolute value of b. All right, and so we either have the product is equal to 0 or it's positive. So I'll do the case when it's equal to 0. So let's see. So call it bullet point 1. So this will be AB equal to 0. So when the product is 0, that means either A is 0, B is 0, or both of them are 0. So I'll do the case when both of them are 0. So both of them are 0. So we have A is equal to 0, B is equal to 0. So obviously, when you have the absolute value of A, that's equal to the absolute value of 0, which is 0, and the same thing for B. And so also when you do A plus B, absolute value, that's equal to 0 plus 0, which we know is 0. Thus, we have A plus absolute value of A plus B equals 0, absolute value of A plus absolute value of B. So that's 0 plus 0, which is 0. And therefore, we've shown, for this case, absolute value of A plus B equals absolute value of A plus absolute value of B. All right, that's when they're both 0. Now, let's do it when A is 0. So if A is 0, B could be positive or B could be negative. Either B is greater than 0 or B is less than 0. So let's do B greater than 0. So this would be like option 1 for A is 0. We have B greater than 0. So we know the absolute value of A is absolute value of 0, which is 0. Since B is positive, absolute value of B is equal to B because B is positive. Also, when I do A plus B, absolute value of that, that's equal to 0 plus the absolute value of B, which is the absolute value of B, and absolute value of B is equal to B. And so when we do absolute value of A plus absolute value of B, A is 0, absolute value of 0 is 0, so that's 0 plus absolute value of b. And that's equal to absolute value of b, which is equal to b. So they both equal b. So then now we've shown the absolute value of a plus b equals absolute value of a plus absolute value of b. All right, now the subcase for which a is 0, we took care of b being positive. Now I'll do b being negative. So b being less than 0. So again, a is 0. So the absolute value of a is the absolute value of 0, which is 0. In this case, absolute value of b, since b is negative, that implies that negative b is positive. So the absolute value of b is equal to negative b. Again, we know and that's positive, but that's just added information. But the point is that the absolute value of b is equal to negative b. So when we do the absolute value of a plus b, a is 0, so that's 0 plus b is going to give me absolute value of b. Absolute value of b is negative b. Then we do absolute value of a plus absolute value of b. Well, absolute value of a is absolute value of 0, which is 0. So 0 plus absolute value of b, which is the absolute value of b, which is negative b. Since b itself is negative, then the absolute value of b is equal to negative b, which is positive. But the point is that they both equal negative b. Okay, so these match. So yeah, we've shown the absolute value of a plus b equals absolute value of a plus absolute value of b. All right, so that took care of when a is 0. Now when b is 0, it's going to be the same thing as what we just did. So it's just different ones, either playing the roles of switching the roles. So a is either positive or a is negative. This is handled just like what I did above. Handled similarly as what we just did for the previous case. All right, so all of that takes care of the case in which the product is 0. Because we did both of them being 0, a is 0 and b is 0. We did the case when a is 0, and then the case where b is 0 is the same as which a is 0, you're just switching the roles of a and b. So now the second option is if the product is positive. So this will be AB is positive. So what does this mean? The product being positive means either both are 0, or sorry, both are positive, or both are negative. So I'll do the option in which both are positive. So A is greater than 0 and B is greater than 0. All right, so the absolute value of A is that's equal to A since A is positive. Absolute value of B is equal to B since B is positive. Since we have A is positive, B is positive, so then when we do absolute value of a plus b, that's going to equal a plus b if a plus b is greater than 0. And it's equal to negative times a plus b if it's less than 0, but we do know that this is true. So this is the case, since the sum of two positive numbers is positive. So the absolute value of a plus b is equal to just a plus b. All right, now when I do absolute value of a plus absolute value of b, so we know absolute value of a is a, since a is positive, so this will be equal to a. And then plus absolute value of b is equal to b, since b is positive, so it's equal to a plus b. So they both equal a plus b. All right, so that takes care of the case when they're both positive. Now the case in which they're both negative. So that means a is less than 0, b is less than 0. Which means negative a is positive and negative b is positive. All right, so when I do absolute value of a, that's equal to negative a, which is positive. And then absolute value of b is equal to negative b, which is positive. Now, when I do a plus b, so the absolute value of a plus b, right, it equals a plus b if the sum is positive, or it equals negative times a plus b if a plus b is negative. That's just definition of absolute value. And we have this second option. So this is the case for this part. Since the sum of two negative numbers, a and b, is a negative number. So since a is less than 0 and b is less than 0. So a plus b is negative. So we have the absolute value of a plus b is going to be equal to negative times a plus b. All right, now the absolute value of a plus absolute value of b. Absolute value of a is negative a. Absolute value of b is negative b. So this be negative a plus negative b. And we can factor the negative. So that'll be negative times a plus b. And they match. All right, so now we've shown the absolute value of a plus b equals the absolute value of a plus absolute value of b in the case in which a is negative, b is negative, because a negative times a negative makes a positive product. All right, so we did the second option when the product is positive. We proved that for both cases, for when a is positive, b is positive, and then a is negative, b is negative. And then we proved for which a times b is equal to 0 for the subcases in which a is 0, b is 0, or both are 0. So therefore, we've shown for the first part that if A times B is greater than or equal to 0, implies absolute value of A plus B is equal to the absolute value of A plus absolute value of B. Now we have to do the other direction. So the forward direction now. So we're going to assume the absolute value of A plus B equals absolute value of A plus absolute value of B. We wish to show the product is greater than or equal to 0. All right, so that's going to be the other part of the proof. And once we've done that, we've done the problem.